All right, you guys, we're going to be learning about radicals and basically simplifying radicals. And what we talked about is how when you have perfect squares, 1 squared is 1, 2 squared 4, 3 squared, that is your perfect squares. We're talking about the numbers kind of in between. So before we get started, here is your parts of the radical. This is your index. This is your radical sign. Right here, this is the radical sign. And the number inside is your radicand. The index for purposes of our class is going to always be 2. Very rarely do you see a number here until you get probably algebra 2. But generally, if it's this, then that is going to just be the square root. If you actually have an index indicated, then that is the number that you are looking at as far as that. A 3 would indicate a cube root. Or you may see a 4, 5, 6. That's to the 4th root. But for purposes of the rest of this year, we're just going to be talking about the square root. So when we have your perfect square roots, here, for example, the square root of 16, we know that the reason the square root of 16 equals 4 is because 4 times 4 equals 16. So you can rewrite this square root of 16 as the square root of 4 times 4, right? So when you do that, you see that there are 2 of the same number under that radical sign, and that's what a square root is saying, that the 2 numbers multiplied by themselves is going to give you that 16. So therefore your answer is 4. What 2 numbers multiplied by themselves is going to, what number is multiplied by itself is going to give you that number? So for an example, in this one, we know that 121 can be rewritten as 11 times 11. We have 2 of them. So when you have a pair of the same number multiplied by itself, you can basically simplify that as just 11. Now in this case, we have this 2 out here. We are multiplying. This is a multiplication sign. So since we can simplify the square root of 121 as 11, 2 times 11 is going to give us 22. All right. Now here, what 2 numbers simplified? How can we simplify this? Is there a number that multiplied by itself is going to give us 289? And the answer is yes. This is going to be, could be rewritten as 6 times 17 times 17. 17 times 17 is 289, which means that if you had a square, you could have 17 columns, 17 rows, and that would form a perfect square. Okay? So to simplify this, 6 times the square root of 289 can be simplified to 6 times 17, which is 102. And again, 400 is a perfect square of 20. 20 times 20 is going to give you 400. So there's 2 of those 20s. What we're going to start doing is we're going to be circling the pairs and knowing that since those are a pair, you can bring them outside of the radical. You take one of those 20s outside of the radical, and I'm going to get 60. All right? So now that we are looking at imperfect squares, there's two ways to do this. I'm going to show you the prime factorization in this video, and then we may go on further to talk about the largest perfect square. But when I'm talking about the numbers 32, I'm looking for numbers that are the same. So I need to find a pair of the same number. And let's see what that looks like. So, for an example, when I think of 32, and here's some kind of tips. When I think of 32, 32 is an even number, so I know it's going to be divisible by 2. 2 goes into 32 16 times. Again, 16 is an even number. I know it's going to be divisible by 2. 2 times 8. Now, I'm going to cross off that 16 because that 16 is now represented by 2 times 8. And I don't want to get confused. I want to make sure that all my numbers are accounted for. So as I go, I'm going to be crossing out that number if it's showing up in a different form. 8 can be 2 times 4. I'm going to cross out that 8 because now 8 is represented by 2 times 4. And 4 can be represented by 2 times 2, so I'm crossing out. So I'm left with 1, 2, 3, 4, 5 2s. So I know that if I were to multiply 2 times 2 times 2 times 2 times 2, I would get 32. That's what I'm basically doing. I'm seeing what are the smallest numbers that can get me 32. Okay, so once I've done this, what I'm looking for are pairs of the same number. A pair means 2. Okay, so right here, there's a pair of 2s. I'm going to circle those. Here's a pair of 2s. I'm going to circle those. But I need to account for every single number. These are all crossed out. I should probably even cross out that 32. And I'm left with this 1, 2 does not have a friend, does not have a partner. Okay? And what we're going to learn is when you simplify, the circled pairs come out as 1. The square stays in. So, as I did up here, if you see up here, we had 2 17s. We can circle that as a pair of 17s and we bring 1 out. So I'm circling those 2s. I'm going to bring one of those 2s out. There's another pair of 2s. I am multiplying. Now, that is all the pairs that I've got. The pairs circle comes out. The square stays in. Then I multiply 2 times 2, and I get 4 square root of 2. Let's do another one. So we've got 180. Now, there's lots of ways you can factor this. 180 we see is an even number. We could divide by 2, get 2 and 90. So we've got 180. What are all the factors? Well, 1 and 180, 2 times 90, right? 3 times 60. I don't know if 4 goes in there. I know 5 is going to go in there. 5 times 16. And I think that might be it. Oh, wait, no. 9 times 20. 10 times 18. I think that might be it now. All right. So we can use any of these, any of those combinations to factor this. And no matter which one we use, we should end up with the exact same number. So just for fun, let's use 3 and 60. I'm just picking that one out of the air. So I've got 3 and 60. No numbers multiply 3. 3 is a prime number, 1 times 3, but that's not going to help us. So what two numbers multiply to give us 60? Again, we've got lots of options. It does not matter what I choose. I'm just going to say, okay, what about 6 and 10? Okay, so I'm going to cross that 60 out. Now, what two numbers multiply to give me 6? Well, 3 times 2 gives me 6. What two numbers multiplies to give me 10? Well, 2 times 5 would give me 10. Now I've got a prime number, prime number, prime number, prime number, prime number. So now I'm ready to start circling my pairs, right? I'm looking for pairs, meaning pairs, not pairs of 2, meaning pairs of the same number. So here I've got a pair of 3s, 2 3s right there. Here I've also got a pair of 2s. But look, my 5 is leftover. So just like you were at a restaurant, you're going to box your leftovers and leave it inside. So when I take 2 out, 2 becomes 1. 2 becomes 1. I take these 2, it becomes 1 3 times my pair of 2s, 1 2, and my 5 stays inside. Now what do I do with this 3 and this 2? I'm going to multiply them together and get 6 square root of 5. Now, you're welcome to try and go through and use any of those numbers if you want to see if that works. I think I screwed that up. I think this is 5 times 36. It should be 5 times 36. Oops, sorry. Anyway, I hope you caught that error. And we're saying that's not right. That should be 5 times 36 is 90. Moving on. So we've got 147. Well, I'm going to look at that, and I think 7 might go into both. 7 might go in there 21 times. 7 goes into 147 21 times. What two numbers multiply to give me 21? Well, 7 and 3. So here are all my numbers. Where's my pairs? I'm circling my pairs. I'm boxing my leftovers. Now be very careful. This does not come out as 49. This comes out as 7, right? You've got 2. It's coming out as one number with your leftovers inside. Make sure the circle is on the outside. The square goes on the inside. All right. Try and do the next few and see if you can do it. Pause the video between each. See if you can do them before you find the answer. So 175, I know 5 can go in there. 5 times 35. What two numbers are going to multiply to give me 35? 7 and 5. Do I have a pair? Yes, I have a pair. There's a 5 and there's a 5. They are together. All right. What's left? The 7. So, I've circled my 5s. The circle comes out. The box stays in. My 5 comes out just as 1, right? 2 becomes 1. And the 7 stays in. All right? Hopefully you guys are getting it. 48. If you haven't done this one already, see if you can try and do it. 48. I know 4 is going to go in there 12 times. Now here's kind of a shortcut. I know that 12 can be 4 times 3. Look at, I have a pair right here. I can break those down further, but I don't need to. I've got a pair. Now I may need to break down this a little bit further, but once I have a pair, I can go ahead and circle that. Circle that. I can't break down 3 any further. I'm going to box the 3, and I'm going to be left with 4 on the outside, 3 on the inside. Now, what if I didn't know to do that? What if I had 48 and I said, okay, 4 and 12, and then I said 4 and 3. 4 can be broken down into 2 and 2, and 2 and 2. So I'm still now left with a pair of 2's and a pair of 2's and box my 3, right? I'm going to take 1, 2 out from this pair times 1, 2 out from this pair, and I'm left with 3 in the box. 2 times 2 is 4, square root of 3, and look at that. They're the same. So it works out both ways. It just saves you a little bit of work if you can find a pair early on. All right, what about this last one? 54. I know that 2 can go in there, 2 and 27. What else is going to go in there? Well, 3 times 9. I have no pairs. I don't know what to do, but I still see that 9 can be broken down into 3 times 3. Now all of a sudden I have a pair. I have a pair of 3's right here, and I'm left with actually 2 leftovers. 2 and 3 are leftovers. They do not make up a pair. They're not the same number. And I can't include this 3 into here because it's only 2. I only need 2. So what do? I'm going to take the 3 out, and I'm going to box my leftovers. 2 times 3. Remember, we're multiplying. We're multiplying. If we were to multiply 2 times 3 times 3 times 3, we would get 54. We have to keep that in mind. Now, the one thing about this one is that there is this 2 outside here. We cannot forget to bring that 2 right there and multiply that. So I'm left with 2 times 3 is 6. Square root 2 times 3 is 6. My answer is 6, square root of 6. All right, hopefully that is helpful.